Welcome back. In the last video, we set up a pre-trained vision transformer and adapted it to be able to be used with our food vision mini problem. And what we're trying to do here is see if we can leverage the benefits of using a pre-trained model. Because in our case, our data is quite limited compared to the original ViT paper. We only have 225 images. So of course we could try to increase that, but using a pre-trained model is probably quicker than collecting more data. And then we have limited training resources. We only have one GPU. And then hopefully, as we've seen before, we can get better results faster. So let's see if that holds true. We'll go down here. We need to start preparing. So preparing data for the pre-trained model, pre-trained ViT model. So this is, I believe, 10.3. Because why? What do we need to pre-train? And I'm just going to put up here, this can be 10.1. Just adjust some of our headings so we can break the notebook down. And then we'll go here. This can be 10.2. 10.2, prepare a pre-trained ViT for use with Food Vision Mini. Turn it into a feature extractor. Wonderful. So preparing data for a pre-trained ViT model is, we need to write down, when using a pre-trained model, you want to make sure your data is formatted in the same way that the model was trained on. So we can look that up in here, in the model page for the vision transformer, ViT B16, which is the one that we built, ViT base with a patch size of 16. And we've got the recipe, that's the training recipe. And here we go, the inference transforms are available at vitb16weights.imagenet1kv1.transforms and perform the following pre-processing operations. So we can access these using the transforms method. So let's try that out. We've done this before. So we want to get automatic transforms from pre-trained ViT weights. So let's have a look at this. So ViT transforms equals pre-trained ViT weights.transforms. And let's have a look. ViT transforms, do we get what we need? Beautiful. That's exactly what we need. Image classification, crop size, resize, mean, standard deviation. These are very similar to the transforms we created right back up here. Except these are, we get them automatically from the pre-trained weights, so we know we're using the right transformations. Now let's set up some data loaders using these transformations. And we'll go train data loader, pre-trained, and test data loader, pre-trained. And class names, we can recreate this variable even though we've already got it. We'll use our ever faithful data setup.create data loaders. And we can pass in the train dir. We should have the train dir still saved as a variable. So let's just check train dir, test dir. And we're getting this function here, create data loaders, from going modular. We created this back in section 5 or chapter 5. Going modular, import data setup. And then train dir is going to be the training directory. The test dir is going to be the test directory. Transforms is going to be equal to ViT transforms. That's going to prepare our images, and then we'll set the batch size. We could set a higher batch size, but we're going to stick with 32. Could set a higher batch size here because using a pre-trained model, and that's something to experiment with if you want to try a few things out. The reason why we can use a higher batch size with a pre-trained model generally is that we don't have to do as many weight updates. So we only have 2,300 updatable weights versus updating all 86 million or thereabouts parameters. So less calculations, less memory. So let's see what happens when we run that. Oh, did we put in the wrong? Where's the doc string? Is it transforms or transforms or transform? I think I said the same thing about 3 times just then. Create data loaders. Oh, just transform. So we'll get rid of that. Wonderful. Now, what should we do? Well, 10.4. We've got our data ready. 10.4, train feature extractor ViT model. So now we're ready to train. And in fact, I'm going to let you take over this and see if you can give it a go. Set up some training code for our pre-trained ViT. And it should look quite similar to what's going on here. So try that out. And if you do, how does it perform against our own custom implementation? Let's find out together in the next video, hey?